Video number 1, 4.2, 4.3, sines, cosines, and tangents. We're going to be looking at our trig functions on the unit circle. And let's start off by defining what cosine, sine, and tangent are. Cosine, you probably, when you first learned about sine, cosine, and tangent, you learned the acronym SOHCAHTOA. And for cosine, which is ca, cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. And tangent is opposite over adjacent. And of course, when we're talking about adjacent, opposite, and hypotenuse, we are talking about the sides in a right triangle. So the hypotenuse, and I would always tell my students to put a squiggly line or highlight the hypotenuse. And the hypotenuse is always across from the right angle. And then depending on where I put theta, I have the opposite and the adjacent. So adjacent means next to, which is why I always label the hypotenuse first, because technically next to this angle are both of these sides. But since this side is already called the hypotenuse, this is the adjacent side. And this one, which is across from the angle, is the opposite side. Now, of course, if I move theta and I put theta, here I'll draw another one. Here. This is still the hypotenuse because it's across from the right angle. That's always the hypotenuse. If I now move theta up to this angle, this is now my adjacent side, and this is my opposite side. It's kind of like how left and right depend on which way you're facing. Opposite and adjacent depend on where the angle is. But hypotenuse is always across from the right angle. Now, on our unit circle, it's called a unit circle because the radius is 1 unit. So if I was to find the circumference of this circle, it would be 2 pi times 1, or 2 pi. So the circumference of this circle is 2 pi. And as we go around the circle, we always begin our circle right here. This is 0 degrees. And as we travel up here to the top, this is 90 degrees. Over here to this side, I'm at 180 degrees. Notice I'm going counterclockwise, which is my positive direction. Then I'm at 270 degrees, and I come back to here, and I'm now at 360 degrees. So right here is either 0 or 360. Now, because what you have to realize is that this unit circle is on, excuse me, the coordinate plane at the origin. So right here is the origin. The ordered pair 0, 0 is right there, which means if I move 1 unit over, the ordered pair here is 1, 0. The ordered pair here would be 0, 1. The ordered pair here would be -1, 0, and the ordered pair here would be 0, -1. Because again, what you need to realize is that we are on a coordinate plane, and we're just right here, and that's 1 unit. So that's how you have to think of what the unit circle is. And what we've done is we've taken this unit circle and we've zoomed up on it and we put it right there. That's our zoomed up version of it. And for each one of these, what we're going to find out is that, and it's the reason why I wrote these trig ratios as cosine, sine, and tangent, is that the x-coordinate on the unit circle is the cosine. And that the y-coordinate on the unit circle is the sine. And the tangent, therefore, is going to be y divided by x. The y-coordinate divided by the x-coordinate. So this is going to be cosine and sine. So the cosine of 0 is 1. The sine of 0 is 0. Up here, cosine and sine. This is going to be cosine and sine. This is going to be cosine and sine. Okay? Now, I want you, what we're going to do is we're going to see how this is true and this works by pulling up our calculator. So let's go to our calculator. So I want you to see that what we have written on the unit circle is true. I want you to see that the cosine of 0 degrees is 1. But in order to do that, I need to go to mode. The default mode on the calculator is radians. As you can see, the fourth thing down, radians is highlighted. So I need to go to where it says radians. I need to arrow over to degrees and hit enter. And now my calculator is in degrees. So now that I've done that, I can type in cosine of 0, and that is automatically 0 degrees, is 1, just like my unit circle said. Let's do another one. Let's do cosine of 90 degrees. Go up to the top of that unit circle and hit cosine of 90, and it means degrees because my calculator is in degrees, and I get 0, just like my unit circle says. Let's go over to the left side of the unit circle, and let's do the cosine of 180. And again, my calculator is in degrees, and I got -1. All right, let's go to the bottom of my unit circle, cosine of 270, and I should get 0. And look at that. And then let's come back to the unit circle to cosine of 360. And once again, I get 1. All right, so what I wanted you to see is that what we did was we went around the unit circle. Cosine of 0, we got 1. Cosine of 90, we got 0. Cosine of 180, we got -1. Cosine of 270, we got 0. Cosine of 360, we got 1. We can do the same thing with sine. So now what we're going to do is we're going to go to our calculator, and we're going to look at all of the sines, and I want you to see how we will get these answers. So let's now go back to our calculator, and let's start on the right side of the unit circle, sine of 0 degrees. Remember, my calculator's in degrees, and I get 0. Just like that y-coordinate says. Then I go to sine of 90. And according to my unit circle, I should get 1. And I did. Let's go over to the left side of the unit circle. Sine of 180. According to the y-coordinate, I should get 0. And I do. Now let's go to sine of 270. And according to my y-coordinate on my unit circle, I should get -1. And I did. Now let's go back to sine of 360. Oops, I hit it twice. Sine of 360. It's a little sensitive. Oh, I am just hitting everything twice. not meaning to do that, sine 360. And according to my unit circle, my y-coordinate should be 0, so I should get 0, and sure enough, I did. All right, so on my unit circle, I want you to notice that I have my sine and cosine, and my sine for 0 and 360. I have my cosine and my sine for 90 degrees right here. I have my cosine and my sine for 180, and my cosine and my sine for 270. So I can go ahead and fill out the first two columns of this table. So when they're asking me for the cosine, that is the x-coordinate. So I am literally going to travel around my unit circle just looking at my x-coordinates only. So 0, I get 1, go up to the 90, I get 0, go over to the 180, I get -1, down to the 270, I get 0, and the 360, I get 1 again. All right, next I'm going to look at my sine, which is my y-coordinate, and I'm going to, again, start here at 0, and I get 0. Go up here to 90, and I get 1. Go to 180, and I get 0. Go down to 270, and I get -1. Back to the 360, I get 0 again. Now, tangent, since it's sine over cosine, is going to be my y-coordinate divided by my x-coordinate. Right? And when I am writing the tangent on the unit circle, I usually put it to the outside. We can do it in the table first, and then we can add it to the unit circle. So y-coordinate divided by x-coordinate for 0 degrees would be 0 divided by 1, which is 0. For 90, it will be 1 divided by 0, which is undefined. You cannot divide by 0. You can try doing it in your calculator, you will get undefined. For 180, we get 0 divided by -1, which is 0. For 270, I get -1 divided by 0, and I get undefined. And for 360, I get 0 divided by 1, which is 0. So I'm going to add that to my unit circle. I got 0 here for the tangent. I got undefined, which I'm going to abbreviate UND. I got 0 for my tangent. And then I got undefined for my tangent. So we are going to look at a diagram of our special right triangles that you learned about in geometry and you should have reviewed in Algebra 2. And you were supposed to learn that in a 30-60 right triangle that there is a ratio of the sides, and that across from the 30 is what we call x. Across from the 60 is x times the square root of 3. And across from the right angle, which is my hypotenuse, is 2x. Now, in this instance, what we are going to do, since it's on the unit circle, we are going to let x be 1. So if x is 1, I can just say that across from the 30 is 1. Across from the 60 is 1 times the square root of 3, or simply the square root of 3. And 2 times 1 just becomes 2. Let's just write that a little better for us there. So those are my 3 sides of my right triangle. Okay. And so when I'm finding the cosine of 30, that is adjacent over hypotenuse, adjacent next to over hypotenuse. So square root of 3 over 2. The